Hey, welcome back to the lecture. So now in this lecture, let's understand about address of variables. So let's write a program to print the address of variables. Let's say we have a variable called my data. So now if you write ampersand my data, so this actually gives you memory location address of my data or memory location address of the variable. So all you need to do is you have to use ampersand sign in front of the variable name. So that actually gives you the memory location address of the variable. So now let's print the addresses of all these variables. So in order to print the address of a variable, there is one a unique format specifier, that is %p. So you can use %p format specifier in order to print the memory location address. So now let's use printf to print the address of variable a1. So let's say address of variable a1 is equal to, you can use the format specifier %p here. So %p helps you to print the address of the variable in hexadecimal format. After that, you can give /n here, and after that, in order to print the address, you have to use the argument here ampersand a1. Let's see what happens. Right, so here it is. So this is the address of the variable, that is a1. So the value 65, that is the ASCII code for a, is actually stored at the location this one. So this is the memory address. So basically what we can conclude from this experiment is that, so there is actually a memory location of 1 byte whose address is this one, and the address size is 8 bytes. So because that code is actually running on 64-bit machine. For 64-bit machine, the size of the memory location address is 8 bytes. So this is the address. So we also call it as a pointer in C because that points to the data, right? And the data is stored at that memory location, and the data happens to be ASCII code of A, which is 0x41. Let's go back to the project. So now let's print the addresses of other variables. So now I'm going to print the addresses of all the variables. Let's see how it goes. So here it is. So here you can see that these are actually consecutive memory location addresses, right? So 7C, 79, A, B, C, D, E, right? So that means your data is actually stored in the consecutive memory location addresses. So now let's run the same code on our machine using Eclipse software, and let's see how it goes. I'm going to open my Eclipse software and I'm going to quickly create new project. Let me copy this code and close this. Let me just compile the code. So code compiled successfully. Actually, there is one warning. So there is a difference between Eclipse IDE, what you use in your PC, and this online IDE. So this online IDE actually doesn't show you all the warnings. So that's one of the drawback of using this online IDE. So here you can see that it is showing this warning that it is saying this variable is unused. So now let's use that, or you can just comment it out, no problem. Let's build once again. The build is clean, no problem. And after that, let's run the project. So here you can see that on our machine, so my machine is actually a 64-bit machine, and it is showing these are the addresses of the variables.